Hello guys, welcome to my YouTube channel Physics Prince. My name is Deepak. I'm going to teach you all 9 subjects of physical science in detail. My courses are absolutely free of charges. My courses are going to help the students who are preparing for CSIR, NET, GATE, NT exam, PhD exam, SET exam, TIFR, Jest, IIT-Jam and other exams related to physical science. Okay, so this is the lecture number 28 of and in which we are going to discuss Fourier transform. Okay, and also I would request the students who haven't subscribed my channel yet, please subscribe my channel and watch my free live lectures which are going to help you to crack the exams related to physical science. Okay, so I'm going to discuss Fourier transform today. Okay, so I'm going to start now. So Fourier transform. Fourier transform. Okay, Fourier transform. So as we know, x is position, okay, and k is momentum, right? K is momentum. So if we know, point is, if we know if we know about the motion of particle, about the motion of particle, if we know about the motion of particle, then we can describe it. Then we can describe it in momentum space, okay, in momentum space using Fourier transform. Okay, in short we can write ft. Okay, so k is the position, x is the position, k is momentum, right? So if we know about the motion of particle, right, then we can describe that motion in momentum space using Fourier transform. Okay, so uh, definitions are like in 1D, in 1D in 1D, Fourier transform is Fourier transform of any function x, any function fx, okay, which is function of x. Okay, so Fourier transform of any function fx is going to be 1 upon root 2 pi, 1 upon root 2 pi integration minus infinity to plus infinity fx e to the power iota kx dx. Okay, or we can say the momentum of the Fourier transform of fx, or we can say that is fk. We can denote it by fk, means function of k. Okay, this is the definition of Fourier transform in 1D. Okay, so Fourier transform of any function is 1 upon root 2 pi minus infinity to plus infinity fx e to the power iota kx dx. Okay, that is equal to fk. And in 3D, in 3 dimension, okay, 3D means 3 dimension. Okay, in 3 dimension, Fourier transform of function f is going to be, for Fourier transform of function fr, okay, is going to be 1 upon 2 pi to the power 3 by 2, okay, and integration minus infinity to plus infinity fr R is the position vector. Okay, Fr e to the power iota k dot r dr, k dot r dr or fk. Okay, so this is in 3D. Okay, Fourier transform of function of fr equal to 1 upon 2 pi to the power 3 by 2 integration minus infinity to plus infinity fr e to the power iota k dot r dr, that is equal to fk. Okay, so this is the Fourier transform in 1 dimension, and this is the Fourier transform in 3 dimension. Okay, so these are the Fourier transform definitions. Okay, now we'll study the properties. Okay, properties of Fourier transform. Properties of Fourier transform. Fourier transform. Properties of Fourier transform. Okay. Meanwhile, just let me check whether I'm audible or not. Then I'll proceed further. 2 pi to the power. Yes, I'm audible. So I'm proceeding further now. Okay. So properties are, first is linearity. Okay. Linearity. That is linearity. 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 Okay. Linearity is fx equal to a1 f1x, right? We can write in some of this a1x plus a2 f2x, this we know, right? This is the linearity definition, f2x plus so on. So in case of Fourier transform, it is going to be Fourier transform of fx. Okay, so this is going to be a1 Fourier transform of f1x plus a2 Fourier transform of f2x plus 1. Okay, and this is the linearity property. Okay, so we can write write like that. Okay, next is change of scale. Next property is change of scale. Okay, change of scale. Change of scale, that is this is Fourier transform of fax. Okay, you have to find Fourier transform of fax, that is going to be 1 upon a. Okay, 1 upon a Fourier transform of fx. Okay, so Fourier transform of fax is 1 upon a Fourier transform of fk. Okay, so here this is the correct one. Okay, or we can write 1 upon a fk. Okay, that is Fourier transform of fx. This is this one. This one is mistake. So this is going to be 1 upon a Fourier transform of k upon a. Okay, Fourier transform of k upon a. So this is the property. Okay, next one is Fourier transform of, this is this change of scale property. Okay, Fourier transform of fax is 1 upon a Fourier transform of k upon a. Okay, fka. Okay, next is shifting property. Okay, shifting property, very important property. Shifting property. Shifting property. Shifting properties. Okay, shifting properties. Shifting properties. So this is a Fourier transform of f(x plus minus a). Okay, so Fourier transform of f(x plus minus a). Okay, so this is going to be e to the power minus plus, okay, minus plus iota ak e to the power minus plus iota ak fk. Okay, so Fourier transform of x plus minus a equal to e to the power plus minus e to the power minus plus, my apology, e to the power minus plus iota ak fk. So this is the shifting property, guys. Okay, next property is Fourier transform of e to the power minus iota ax fx. Okay, so Fourier transform of e to the power minus iota ax fx. So this is going to be Fourier transform, that is f k plus a. Okay, f k plus a. So Fourier transform of e to the power iax into fx is going to be f k plus a. Okay, function of k plus a. Okay, so similarly, next property is Fourier transform of e to the power iota ax plus iota ax. Okay, into fx is going to be f k minus a. F k minus a. So we have made mistake. So this is plus iota. Okay, e to the power iota ax fx is f k plus a, and e to the power, this is minus iota. Okay, minus iota ax fx is f k minus a. Okay, now we'll solve one example. So here, like Fourier transform of e to the power iota ax fx. Okay, we have to prove that. Okay, so this value we have to prove. We know this value is Fourier transform of e to the power iota ax fx is f k plus a, right? So if we have to prove it, so how we are going to Fourier transform of this is going to be by definition, right? This is going to be 1 upon root 2 pi, right? Integration minus infinity to plus infinity. This is the function, right? E to the power iota ax into fx and e to the power iota kx dx, right? Or we can write 1 upon root 2 pi minus infinity to plus infinity fx, and these are equal base, so powers will be added. So e to the power iota k plus a x, right? E to the power iota k plus a x dx, and this is, we know that is f k plus a, right? This one f k plus a. So we have proved it as well. Okay, so because this is iota k plus a, right? So this is f k plus a. So this is proved. Next is there are third theorem. Okay, modulation theorem. Modulation theorem. Okay, modulation theorem. Okay, okay. So so their property. So this is Fourier transform of fx cos x. Okay, so we have to find Fourier transform of fx cos x, and so this is going to be 1 by 2 Fourier transform of k plus a plus Fourier transform of k minus a. Okay, this is Fourier transform of fx cos x is this. Fourier transform of f k plus a plus f k minus a. Okay, next is Fourier transform of fx sin x. So this is going to be 1 upon 2 and this is going to be f k plus a minus f k minus a. So guys, you need to revise it and practice these formulae which I am writing, okay, these properties, and you need to solve questions using these properties. Then you will be able to memorize these properties, and these properties are very important for examination purpose. Okay, so this is the Fourier transform of fx sin x. Fx sin x is 1 upon 2 f k plus a minus f k minus a. Okay, next is Fourier transform of x into fx. Okay, x into fx. So this is going to be minus iota d upon dk fk. Okay, so this is a Fourier transform of x into fx. It is minus iota d upon dk fk. Okay, now in the same manner, Fourier transform of this x to the power n fx. Okay, if we have to find out this Fourier transform of x to the power n fx. Okay, so this is going to be minus iota to the power n to the power n dn upon dkn d to the power n upon dk to the power n fk. Okay, this one very important. Next property is Fourier transform of fn x. Okay, so nth derivative of x, Fourier transform of nth derivative of x, and that value is going to be minus iota k to the power n minus iota k to the power n fk. Okay, minus iota k to the power n fk, very important. So nth derivative of x. So in the same way, we can easily find out Fourier transform of f double dash x. Okay, Fourier transform of f double dash x. So this is going to be minus iota k to the power 2 fk, k to the power 2 fk. Okay, this is the one. Next, Fourier transform of integration 0 to x fx dx. Okay, if we have to find the Fourier transform of integration 0 to x fx dx, then this value is going to be fk upon minus iota k. Okay, very important. So Fourier transform of any integration 0 to x fx dx is going to be fk upon minus iota k. Okay, minus iota k. Next property is Fourier sign transformation. Okay, Fourier sign transformation. Fourier sign transformation. Fourier sign transformation. Okay, so Fourier sign transformation is going to be, okay, Fourier sine transformation of fx. Okay, Fourier sine transformation of fx is going to be this is a very important formula, guys. You can solve integration easily. Okay, so Fourier Fourier sine transformation of fx, Fourier sine transformation of fx is going to be root 2 upon pi, root 2 upon pi integration 0 to infinity fx sine kx dx. Okay, this is very important because by using this formula you can solve integrations whose limit is between 0 to infinity, right? So this is the Fourier sine transform of fx. Okay, root 2 upon pi integration 0 to infinity fx sine kx. Okay, similarly Fourier cosine transformation of fx is going to be, this is Fourier cosine transformation we say. Okay, so Fourier cosine transformation of fx is going to be, that is going to be root 2 upon pi integration 0 to infinity and that is fx cos kx dx. Okay, so Fourier cosine transformation of fx is going to be root 2 upon pi okay, 0 to infinity fx cos kx dx. Okay, so these are Fourier sine transformation formula and Fourier cosine transformation formula for any function of x. Okay, well, these are the property. Now I'll write some important integrations, okay, by which you can easily solve integration. So integrations are going to be very easy. Okay, so important integration. Okay, important integration. Important integrations. Okay, very important integrations, so you can easily solve questions. Okay, the first one is integration 0 to infinity sin x upon x. Okay, integration 0 to infinity sin x upon x dx. You have to find this integration. This integration is 0 to infinity sin x upon x dx. This is pi by 2. Okay, you need to note down and memorize it, guys, and solve and use these formula in questions. Okay, the second is integration 0 to infinity e to the power minus ax sin bx. E to the power minus ax sin bx is going to be b upon a square plus b square. Okay, sin bx dx. Okay, so integration 0 to infinity e to the power minus ax sin bx dx is going to be b upon a square plus b square. Okay, and next is integration 0 to infinity e to the power minus ax cos bx dx. Okay, cos bx dx. So this is going to be b upon, sorry, this is going to be a upon okay, so this is going to be a upon a square plus b square. Okay, so e to the power integration 0 to infinity e to the power ax cos bx dx is going to be a upon a square plus b square. Okay, so if there is a sign, then it is going to be b upon a square plus b square. If there is a cos, then a upon b square, a square plus b square. Okay, next point, next is, I'm going to write here, next is integration, very important. Okay, integration minus infinity to plus infinity e to the power minus ax square plus bx dx. Okay, very important integration, so you can easily solve questions. Okay, so integration 0 to infinity sorry, integration minus infinity to plus infinity e to the power ax plus ax square plus bx dx. Okay, that value you need to find. So this value is root pi upon a, okay, e to the power b square upon 4a, okay. So this integration minus infinity to plus infinity e to the power minus ax square plus bx dx is going to be root pi upon a, okay, root pi upon a e to the power b square upon 4a, okay. Next is, this is important one, integration 0 to infinity, okay, integration 0 to infinity e to the power minus ax square cos ax square cos bx dx, okay, cos bx dx. This value is going to be very important. This value is going to be 1 upon 2 root pi upon a e to the power minus b square upon 4a, okay. This one very important. So integration 0 to infinity, okay, 0 to infinity e to the power minus ax square cos bx dx, okay. This value is going to be 1 upon 2 root pi upon a e to the power minus b square upon 4a, okay. These are important integrations which you need to note down and memorize it by practicing questions, okay. Next, next is question, okay. We are going to solve question. So question is fx is given, guys. Fx is given, that is e to the power minus a square x square, okay, e to the power minus a square x square, and you need to find out Fourier cosine transformation of fx, okay. Fourier cosine transformation of fx we need to find out. So this is the fx is given, and Fourier cosine transformation of fx we need to find out, okay. So this we know this Fourier cosine transformation of fx is going to be, Fourier cosine transformation of fx is going to be, this is we know, right. So this is root 2 upon pi, root 2 upon pi, okay, root 2 upon pi integration minus infinity to plus infinity, sorry, my apologies. So this is integration 0 to infinity, so integration 0 to infinity fx, that is e to the power minus ax square fx, and I'll write first then root 2 upon a, this is fx e to the power iota kx dx, right. So this is going to be root 2 upon pi, okay, integration 0 to infinity, fx value is e to the power minus a square x square, okay, e to the power iota, sorry, my apology, it's a cosine, right, Fourier cosine. So this is going to be cos kx dx, okay, cos kx, right. So this is going to be cos kx dx, okay. Now we know this formula, e to the power minus a x square alpha x square, here alpha is a square, right, alpha x square cos x dx, this value I have already explained here, 0 to infinity, this one 0 to infinity e to the power minus a x square cos bx dx equal to 1 upon 2 root pi upon a e to the power minus b square upon 4a, okay, right. So this is going to be root 2 upon pi, okay, and this value is going to be 1 upon 2 into root pi upon a square, right, because here alpha is a square, okay, a, and then e to the power minus b square, e to the power minus b square is this one, e to the power minus b square, okay. So this is k square, right, this is b, This is b, right? So minus k square upon 4a. 4a is k square, right? K square upon 4a. Now very soon, now we can easily solve it. So this is going to be 2 will get cancelled. So this value is going to be 1 upon pi will get cancelled, okay, and 2 will cancel with root 2. So a root a square is going to be a. So a root 2 e to the power minus k square upon 4a, right? So so this Fourier cosine transformation of fx is going to be 1 upon a root 2 1 upon a root 2 1 upon a root 2 e to the power minus k square e to the power minus k square upon 4a minus k square upon 4a. This is the answer, guys. Okay, well, this is the answer. I hope you understood it. Okay, very simple. Next question we are going to solve. Next question is, fx is given that is a. Okay, fx is given a when mod x is less equal to a. Okay, and value of fx is 0 when x is greater equal to. So this means this means uh, x is between minus a to a, right? Because mod x less than equal to a, right? So x is between this one. Okay, so this is given. Okay, so we need to find Fourier transform of fx. Okay, we have to find Fourier transform of fx, right? So I'll solve it now. So Fourier transform of fx Fourier transform of fx is going to be this, we know, right formula. This is going to be 1 upon root 2 pi 1 upon root 2 pi integration minus infinity to plus infinity fx e to the power iota kx dx, right? So here we'll put the value 1 upon root 2 pi, and this value is going to be minus infinity to plus infinity a e to the power iota kx dx, and the limit is going to be, this value is between minus a to a, right? Because mod x is between mod x is less than equal to a, right? So this is the value. Okay, so now what we are going to do is we are going to solve it. Okay, well, so this is going to be next. This is Fourier transform of this. So we can write f here, right? This value is going to be a upon root 2 pi. Okay, and this is going to be integration minus a to a e to the power iota kx dx, e to the power iota kx dx, right? This one, e to the power iota kx dx. So fk value is going to be a upon root 2 pi. Okay, this integration we know, right? So this is going to be e to the power iota ka upon iota k minus a to a, right? And this is going to be we can write it a upon root 2 pi, and this value is going to be e to the power iota ka minus e to the power minus iota ka, and we can multiply by 2i and divide by 2i. Okay, and there we have ik is also here. So right, so this value, this ii will get cancelled. Okay, and so this value is going to be 2a upon k root 2 pi, and this value is sine k, right? So value of f is 2a upon uh, k root 2 pi, 2a upon k root 2 pi, okay, and sine k. So this is the value. Okay, right. Okay, right. So next we are going to solve. This is the answer. Okay. Have you made any mistake? This is 2, and this value is coming a upon k root a upon k root 2 pi sine k, right? Okay. Next question is question third. Question third is we need to find the value of 0 to infinity sine ka upon k. Okay, k upon k. Whole square dk. This value we need to find. I equal to 0 to infinity sine ka, 0 to infinity sine k upon k whole square dk. That we need to, this value we need to find out, guys. Okay, so we will use a Fourier identity here, but before that I'm going to explain what is Fourier identity. Okay, so Fourier identity. Fourier identity. Okay, Fourier identity. So this is, first is, there are two identities. In the first is integration. Just give me 1 second, guys. Okay, okay, guys, thank you. So now Fourier identity is, this is integration minus infinity to plus infinity f star x gx dx. This value is going to be minus infinity to plus infinity. Okay, minus infinity to plus infinity f star k fk, right, and gk dk. Very important property, guys. So minus infinity to plus infinity f star k gk dk. Okay, so this is the first identity. Okay, the second identity is minus infinity to plus infinity. This is very important identity. Mod fx square. Okay, mod square of fx dx. This value is going to be minus infinity to plus infinity. Okay, mod square of fk dk. Okay, so very important. These two properties are very important, and these two properties are called Parseval's identities. Okay, so minus infinity to plus infinity, mod square of fx dx equal to minus infinity integration minus infinity to plus infinity mod square of fk dk. Okay, well, so now we'll solve this question. Okay, so this question we need to find out this value, integration 0 to infinity sine k upon k whole square dk. Okay, this one. Okay. Okay, so since we have given, and here fk is defined. Okay, we'll define the fk for solving this. I have already we have already explained this, right? So this is fx is a when mod x is greater than a. Okay, and fx equal to 0 when x greater equal to a. Okay, so this continuation of the same question which we have solved now, right? So this is this we have defined, right? So from here we'll use the so from here we have fk value we have got it, right? So fk value is root 2 upon pi a sine ka upon k. Okay, this we have got, this one, root 2 upon pi, this one, root 2 upon pi. So here we have made a mistake, I think. This one, yeah. Just give me 1 minute. So here 2 is here and 2 is here as well, right? So this value is going to be a upon k I had to get cancelled, right? A upon k, 2 is here, right? So this is going to be 2 upon root pi sine k. Okay, this is the answer because 2 is also here and root 2 will get cancelled. So root 2 upon pi sine k. This is the answer actually, right? And if this is the function, then this answer we know because I have already solved it for you. Okay, so this is the value of fk, right? So now we are going to use Parseval theorem. Okay, Parseval identity. So here this is the value of fk. Fk is, we know, right? Integration minus infinity to plus infinity and root pi upon root 2 upon pi root 2 upon pi, right? Fx square, right? So this is fx square means root 2 upon pi root 2 upon pi here, right? This value we are putting. So this value we can write here fk is this a sine ka upon k whole square dk. right? This value is going to be integration minus infinity to plus infinity mod square of fx dx, right? This identity we have used. This integration integration minus infinity to plus infinity mod square of fx dx is minus infinity to plus infinity mod square of fk dt, right? So this one, right? Because this is the value we have used, this percival identity mod square, right? So this is mod square also, we can say this is mod square, okay? And this is also a square, right? Right, because we know here mod square of minus infinity to plus infinity mod fk square equal to minus infinity plus infinity mod fx mod square of fx, right? So fk value is this, so we have put mod fk square value we have put here, okay? So this is actually mod, okay? So this value is going to be square means 2 upon pi a square, right? This is mod a square, 2 upon pi mod a square, okay? And this is going to be integration minus infinity to plus infinity, and this value is sine k upon k mod square, or you can say whole square, same thing, okay? Dk. And this value is going to be mod fx, this value is a, right? So mod fx, mod square of fx means mod a square we take outside, minus infinity to plus infinity dx, and the limit is going to be here, limit is going to be minus a to plus a, right? We have used percival, that is we have used percival identity, right? From here this will get cancelled, okay? And this value is going to be integration minus infinity to plus infinity sine k upon k whole square. This is going to be this will be here, this is going to be, this is 2, right? 2 and 1, 2 by 5, right? So this is going to be this, this is the integration, and this integration is x minus a upon a, and this part, this one, 2 upon pi will go in right hand side, pi upon 2 will become pi upon 2, pi upon 2, right? Okay. So this is going to be, this one is guys, you can see this is whole square, right? So whole square means dk, okay? Whole square means this is a even function, guys. Even function means we can break the limit, so we can write 1 upon 2 0 to infinity sine k upon k whole square, right? Dk, and this value is going to be pi by 2, and we'll put limit here, so x minus a, right? So this value is going to be integration 0 to infinity sine ka upon k whole square dx. This is going to be 2 will get cancelled, right? This is 2, right? So we'll break the limit, right? So this is 2. So this is going to be 1 by 5 by 4, right? 5 by 4, and this is 2a, 2a pi by 4. This 2 will come here, right? So this is going to be a pi by 4, right? This is the answer, guys. So we have used Percival's identity, this identity, okay? And function is we have taken this function, okay? This is f equal to a, f equal to a1, right? This one, f equal to these conditions, and then we put the value. We have used Percival identity, and finally we got the answer. This is the integration of this value. This one is a pi by 2. My apology, it's a pi by 2. A pi by 2. Okay. So this is the possible identity and the question. Now next question we are going to solve. Before solving that question, I'll tell you some property. Okay. So property is Fourier transform of del dash x. Fourier transform of del prime x. Okay. Del dash x. Fourier transform of del dash x. That is minus iota k upon root 2 pi. Okay, minus iota k upon root 2 pi. Okay, so Fourier transform of nth derivative of drag delta x. Okay, so this is going to be minus iota k to the power n upon root 2 pi. Okay, minus iota k to the power n upon root 2 pi. So similarly, Fourier transform of del x. Okay, this is going to be Fourier transform del x is going to be, this is 1 upon root pi. Okay, these are very important property you need to know. Okay, so Fourier transform of del dash x is minus iota k upon root 2 pi, and Fourier transform of nth derivative of drag delta x is minus iota k to the power n upon root 2 pi, and Fourier transform of del x is drag delta x is 1 upon root 2 pi. Okay, so guys, these are identities. You need to practice it, guys. You need to revise it, then you will be able to memorize these formulas. Okay, so this property, now I'm going to solve question. There's a question which is asked in CSIR net December 2015. Okay, CSIR net December 2015. This question is asked. Okay, so here, since we know fk value, right? Fk value we know, so we have been given fk value is given here in this question. Fk value is given minus infinity to plus infinity. Okay, 1 upon root 2 pi is not given, that value is 1. Okay, so minus infinity to plus infinity, fx e to the power iota kx dx. Okay, so this is the fk value is given, that is Fourier transform of fx. Okay, this is given in the question, and okay, and fx value is given, that is alpha drag delta x del x plus beta delta dash x plus gamma delta triple dash x. Okay, this is given a value of fx, and we have to find out Fourier transform of Fourier transform of fx. Okay, Fourier transform of fx we need to find. This is the question asked in December 2015. Okay, so I'm going to solve it. So we have been given fx is given, so Fourier transform of fx is going to be Fourier transform of alpha delta x, Fourier transform of alpha delta, Fourier transform of alpha delta x plus Fourier transform of this one beta delta dash x plus Fourier transform of gamma delta triple dash x. Okay, this is okay. So we Fourier transform of this Fourier transform of delta x is I have already done, right? So this is delta dash x is 1 upon root pi, right? But here definition of Fourier transform is given like this. Okay, so 1 upon root pi is not here, so this is 1. So this value is going to be alpha into 1 plus Fourier, this is beta, and Fourier transform of delta dash x is going to be iota k minus iota k. Okay, minus iota k plus Fourier transform of del triple dash x is going to be this is so this is, guys, just del double dash x is given. Okay, del double dash. So this is going to be del double dash. So del double dash x is going to be minus iota k whole square, right? So solve it. So alpha minus iota beta plus this is going to be I square minus I square minus I square is I square value is 1, so minus k square gamma. So this is iota k. So this value is alpha minus beta ik minus gamma k square, right? This is the answer, guys. Very simple question asked in December 2015. Okay, alpha minus beta iota k minus gamma k square. Okay, well, next question, guys, we are going to solve. Question number 4, I believe. Question number 4 is we have given ht. Okay, ht value is given plus 1 if t greater or equal to 0, and ht value is minus 1 if t less equal to 0. Okay, this is given, and f Fourier transform of ht is given, that is minus 2i upon omega, that is f omega. Okay, and you have to find out I, that is Fourier transform of 1 by 2 ht, Fourier transform of 1 by 2 t plus half. Okay, minus 1 by 2 h t minus half. Fourier transform of this, okay, you need to find out. So here so at Fourier transform of ht is given minus 2i upon omega. So here you can see, so instead of k, omega is given, or instead of x, t is given. Okay, same thing. Okay, so we have to find this value, guys. We'll use property and solve it, guys. Okay, so I'm going to, so first I'll find Fourier transform of, this is okay, a Fourier transform of 1 by 2 h 1 by 2 h t plus half. Okay, this we are going to find out. So we know the shifting property, right? So this is going to be 1 by 2 e to the power minus so this is the a, right, value, so minus 1 by 2 iota 1 by 2 omega, right? This is the shifting property we have used. Similarly, the value of Fourier transform of h t minus half. Again we'll use this shifting property, so this is going to be 1 by 2 into e to the power, this is minus, right? So plus iota by 2 omega, right? Because we know the shifting property, that is a Fourier transform of f x plus a, right? This value is e to the power minus iota e to the power minus iota ak and fk, right? This we know. So that property we are using. Okay, so this is going to be e to the power n f omega, right? This is the shifting property we are utilizing. Okay, so this is minus, this is this is minus plus. Okay, this is the shifting property. So this is omega, and here is also omega, f omega. Okay, so now we will put the value in I. Okay, so I is going to be, the value of I is going to be, we'll write it 1 upon 2 e to the power minus I by 2 omega f omega, and this is going to be minus 1 by 2 e to the power I by 2 omega f omega, right? F omega. So this value is going to be 1 by 2. Okay, we will put the value 1 by 2 e to the power minus iota by 2 omega, and this value is minus 2i upon omega, minus 1 by 2 e to the power I by 2 omega, minus 2 iota upon omega. This is the value of I. So we'll calculate it. So this is going to be iota upon omega will take common. So this is going to be e to the power iota omega by 2 minus e to the power minus iota omega by 2. Okay, and here we can multiply by 2i and divide by 2i. Okay, so iota is going to be, this is going to be 2 iota square by omega, and this value is going to be sine omega by 2, right? Because e to the power, this value we know, right? E to the power x minus e to the power minus x upon 2i equal to sine x, right? So this is sine omega by 2. So this value is going to be, I square value is 1, so minus 2 upon omega, minus 2 upon omega, minus 2 upon omega sine omega by 2. Okay, so this is the answer, guys. Well, okay guys, so before ending the class, I would request the people who haven't subscribed my channel yet, please subscribe my channel and watch my free live lectures, which are going to help you to crack the exams related to physical science. Okay, next class is going to be quantum mechanics class. Okay, just after this class. Okay guys, thank you, bye now.